Okay, so now we should reach out and crank that difficulty meter one more notch to the right. You've done one-step problems. We've done two-step problems. Now it's time to do compound factor label. Compound factor label is a combination of two units. Examples are units for speed, like meters per second, or kilograms per hour, or even milligrams per kilogram. Combinations of two units in one problem. To do this is kind of difficult, so feel free to pause the video. Make sure that you can even rewind it if you need to make sure that you can follow along with what's happening. Of course, no matter how hard the problem, you always start it the same way. 3.5 centimeters per second. You'll notice we've been leaving this bottom left box blank. We've just been waiting for this type of problem to do it. Because our original units were in a fraction, then our factor label has to start in a fraction, centimeters over seconds. And the first thing I want you to do is to just ignore the seconds in the bottom left. Focus just on changing centimeters to meters. That's two letters to one letter, so we know that that part is going to be a one-step problem. We'll put centimeters down below to cancel, and meters on top. According to the chart from section 1, meters is bigger, it gets the 1, and centa means 100. Cancel out centimeters. Now we have meters per second. But that's not quite good enough. Our answer has to be meters per minute. So we need to add one more step. Now that we've started this section, this is the major mistake that we see. Seconds is on the bottom. So in order for it to cancel, it must go on the top. Remember that seconds was on the bottom originally, so to cancel it must be in the opposite location, which is the top. So we have seconds on the top, and we can convert seconds to minutes. Minutes is larger, it gets the 1, and of course there are 60 seconds in a minute. You do the math the same way, multiply across the top, then divide, then multiply to the top, then divide again. The answer is 2.1 meters per minute. I think we should try one more. This one is a little more complicated simply because the individual steps are 2 steps each. We're going from decigrams per millisecond to centigrams per kilogram. So decigrams to centigrams is 2 steps, and they have G in common. So we'll go from decigrams to grams, then to centigrams. And then we do the bottom half of the problem, which is milliseconds to kilograms. Something's not right there. We should change this to kiloseconds. Milliseconds to kiloseconds. And these two have the same unit of seconds. So it'll be milliseconds to seconds, and then seconds to kiloseconds. All of this means that we start with what we're given. 8.07 decigrams per millisecond. Again, we were given a fraction, so we have to start our factor label as a fraction. Put decigrams in the bottom to cancel. And remember, it's going to take 2 steps, so we'll go from decigrams to grams. Grams gets the 1, and deci means 10. Decigrams cancels, and we carry it out one more step. You have grams here, so we must cancel it down below, and we change it to centigrams on top. Grams is bigger, it gets the 1, and centa means 100. Right now, the only units that aren't marked out are centigrams on top and milliseconds on the bottom. That's not quite good enough. We have to have centigrams, that's half of the answer, but we have to get it to kiloseconds. Watch out for this. Remember, milliseconds is on the bottom, so to cancel it must go on the top. Milliseconds goes on the top. And to go from milliseconds to kiloseconds has to take us through seconds. So we go from milliseconds to seconds. Seconds is larger, it gets the 1. And milli means 1,000. Milli cancels out. Now we have to go from seconds to kiloseconds. And once again, notice seconds is on the bottom. So to cancel it has to go on the top. Kiloseconds down below. If you look back at that chart from the first section, you know kilo is bigger, it gets the 1. And the prefix kilo means 1,000, so we'll put 1,000 seconds per kilosecond. We can cancel out seconds. This is a pretty long problem, but you do the math the same way. Multiply across the top, then divide by the bottom, then multiply, then divide, multiply, divide, multiply, and finally divide one last time. When you do this, it all works out to be 80,700,000 centigrams per kilosecond. Compound factor label is one of the toughest types of factor label we do.